Welcome to this Wood Solutions Campus presentation on carbon storage in timber. Timber and wood products can contribute to a low carbon economy in three ways. First, forests can store atmospheric carbon. Second, timber and wood products taken from the tree can store atmospheric carbon in the building. And third, using timber products avoids the use of fossil fuel intensive alternative materials. This presentation deals with the last two of these points: how timber and wood products can store carbon and how using them avoids more fossil fuel intensive alternative materials. Carbon stored in the tree is retained in wood products recovered from it. Approximately half of the timber's bone dry weight is atmospheric carbon.
So this is a pack of 12mm non-structural plywood, Australian made. It would weigh, it's 45 sheets, it would weigh around about 840 kilograms, and up to 50% of that, or around 50% of that, would be atmospheric carbon.
So each tonne of seasoned timber used in the building equals about 450 kilograms of atmospheric carbon. A cubic metre of seasoned softwood sequesters about 250 kilograms of atmospheric carbon, or about 0.9 tonne of carbon dioxide. A cubic metre of denser seasoned hardwood sequesters about 300 kilograms of atmospheric carbon, or more for harder and denser species. This equals about 1.1 tonne of carbon dioxide. The process of harvesting and manufacturing timber products results in carbon dioxide emissions. These have to be deducted from the carbon sequestration in the material to give a net carbon dioxide storage for the product. This diagram shows the results from a detailed audit of this process. It shows the carbon dioxide sequestered in 1 cubic metre of kiln-dried softwood. It's 900 kilograms. The emissions that occur along the way and the amount of carbon dioxide stored in the buildings or in landfills, 570 kilograms. This diagram provides the same information for 1 cubic metre of denser kiln-dried hardwood. 1,280 kilograms of carbon dioxide is sequestered in the wood. Emissions occurred during harvest and processing, and the net amount stored in the buildings or in landfills after these emissions, 611 kilograms. This carbon remains stored in the timber product until the material is eventually removed and either burnt or it breaks down naturally. Storage can be long-term. This is the inside of the Melbourne Exhibition Building, completed in 1880. Most of the building's internal structure and finishes were sawn timber, and that has been sequestering atmospheric carbon in the building for at least 135 years so far. It will continue to do so as long as the timber remains in this or another building. This amount of carbon storage in timber products can be significant. A conventional 2-storey timber-framed home like this one can contain about 16 metres cubed of mainly softwood timber in the structural frame. The house sequesters about 14.2 tonnes of carbon dioxide in the timber, and this is a net storage of about 9.1 tonnes of carbon dioxide after allowing for milling and processing. Australia's buildings stored 103 million tonnes of atmospheric carbon in wood products in 2010. This was equivalent to 377 million tonnes of atmospheric carbon. There is another carbon benefit when timber and wood products are used. Using timber avoids the use of alternative materials. This is important as the manufacture of most other materials produces large amounts of carbon dioxide and is often dependent on fossil fuels such as coal, oil and gas.
And it's interesting if we actually do a comparison of two elements. And I've got two elements here. I've got a steel element. This is a 150 by 75 steel I-beam. And this timber element here. This is a 240 by 85 piece of glue laminated hardwood material. So there's a lot of commonalities between these two pieces. They're the same length. They have about the same weight. This is about 4.5 kilos, this is about 4.4, 4.3 kilos. So these pieces have been selected to have exactly the same bending stiffness. That means if we used either of these in a floor, then they'd be interchangeable. So they're the same weight. This one isn't as high as this one, so this one's a bit bigger. They weigh about the same, but the difference really we can see is if we look at the amount of carbon that is either stored or released by using these two things in a design. With this piece, if we use this in a structure, we're going to end up storing about 1.4 kilograms of atmospheric carbon for each piece this big. Now that includes the amount of atmospheric carbon that's in the piece, but also allows for the amount of atmospheric carbon that might be released by making this piece and by using the glue and transporting the material to sites. So that's taken into account with this piece. With this piece of steel, by manufacturing the steel, we're going to have to use a lot of carbon and other fossil fuels to manufacture this piece of steel. So when we look at this, we can see that the amount of carbon that we're releasing to manufacture just this small piece of steel is about 1.5 kilograms of carbon are emitted. So between the two, we release 1.5 kilograms of carbon into the atmosphere by using the steel. With this piece, we actually store 1.4 kilograms of carbon in the building, atmospheric carbon in the building, if we use this piece. So we've got a difference there of 2.9 kilograms of carbon just in each of these individual lengths to achieve exactly the same stiffness in our floor. And if we looked at that in CO2 equivalents, it works out at about 10 kilograms of CO2 for this length, or if we went per lineal metre, our difference is about 34 kilograms per lineal metre. So each decision where we choose this material over that one, we're 34 kilograms of carbon dioxide emissions better off by picking the wood than we are with picking the steel.
These benefits are recognised internationally. To quote the fourth assessment report of the Intergovernmental Panel on Climate Change from 2007, wood products can displace more fossil fuel intensive construction materials such as concrete, steel, aluminium and plastics, which can result in significant emission reductions. In summary, carbon stored in the tree is retained in wood products. Half of the timber's bone-dry weight is atmospheric carbon. The carbon remains stored in the timber product until the material is eventually burnt or it breaks down naturally. Australia's buildings stored 103 million tonnes of atmospheric carbon in 2010. Using timber in buildings avoids the use of alternative materials whose manufacture produces large amounts of carbon dioxide.